sleeves. Great. Look like it. Look, rock, paper, scissors again. So weird. Good. There we go. All right. I give up. Just do it right. Today, the problem of the day is the smartboard happens to work, but it's a little bit flashy for people sitting in the classroom. So if you're subject to seizures, now is not a great time to look at the board. I apologize. And I'm semi-serious about that, semi-not. All right. Somebody told me I have to do problem number 7. What are the problems I need to do? I'm going to do it. We're probably going to I asked you to do 1, 2, 3, 5, 7, right? Which problem do you want? Felt good about all of them? Okay. Who didn't feel good about each one? 1. Problem number 1. Okay, 1 and 7. You know what to do? 2. Here, 1, 2, and 7. By the way, by volunteering, I'm picking on you for helping with it while writing on. Let's do 1. Okay, so 1 starts off, f of x equals the bracket 1 if x is greater than or equal to 2, x if negative 1 is less than or equal to x, which is less than 2, and negative x minus 3, it's getting worse, or it's getting worse, x less than negative 2. All right, so I'm going to designate this one here green. That's going to be a green graph. This is my purple part of the graph. And this is my blue part of the graph. Fair enough? Which, Farrell, right? Okay. All right, Miss Farrell, let's do this problem together. F of x equals 1 if x is greater than 2, right? So, x is greater than 2 is, this is x equals 1. That's 2, that's 3, that's 4, that's 5. So since this is 2, it's going to be this way and over. Okay? And as such, now all I have to do is graph this function, which is y equals 1. How do I graph y equals 1? On the 1? Okay. So you're going to start here. So you would normally graph like this, but I'm only going to graph the part that is where x is greater than 2, right? So I start here. It says equal to, so I'm going to fill in my dot. I'm going to draw an arrow that way. Then y equals x. I graph that. Y-intercept of 0. Slope of 1, so up 1 over 1. So here's my points. I would normally graph it like this, right? When I hit 2, I stop. It's not equals 2, so I put an open circle on that end. On the left side, I'm going to stop at negative 1. But it's equal to, so I put a filled in circle right there. Good. Good. All right, and then over the last part, I'm going to go from negative 2 So normally I graph this as negative 3, 1, 2, 3, negative 3. Slope is negative 1, so down 1 over 1, down 1 over 1. But I don't care about this direction. I got to go this way. So I go up 1 over 1, up 1 over 1. I get to here. Suddenly I care. Not equals 2. So I leave an open circle here, and I just keep going with my graph. Ta-da! All right, sir. What are you looking on your screen, by the way?
Me?
Yeah.
I was seeing myself. I know my file.
You just see if your what's open?
Making sure my assignments.
Okay. All right. Close that back up and get those things get distracted. I can't leave them open without looking at my email. I shouldn't look at my email. That's bad. I know, email. What's that stuff? All right. You're up next, sir. You've got this ugly one. It's 2. And it's f of x equals, and I've got 3 brackets again. I've got -2 if x is less than or equal to -1. It's 1 plus x if -1 is less than x, which is less than 2. And 1 minus x if x is greater than 2. So far, so good? All right, let's get this thing done then. We're going to go set up our graph paper. Wow, it is getting ridiculous now. This one here, I graphed when x is less than or equal to -1. So along this line right here, my boundary. How do I graph y equals -2? Dot at -2. Straight line across. Now I don't graph this side over here at all. It all starts here, build in, and goes left. Now from -1 to -2, x equals -2 is right here. I'm now going to look at my graph and go x plus 1. How to graph x plus 1?
Put the y plus 1.
Put the y-intercept at 1.
Go up 1.
Up 1 over 1.
Make
Up
sure
1.
it stays in between the 2 lines.
And it's just trapped between those 2 lines, so we stop it before it gets out.
And
And
open circle.
Open circle. Open circle. I'm sorry, you should have said that. I get used to monologuing up here. I apologize. All right, let's do the last one together. Write that down right? Yes, I did. What do I do?
X is greater than 2, so put a dash line down to 2.
Okay.
And then put the y at 1. And then put a negative x all the way from.
Y at 1. What do you mean by negative x?
Go, just keep going down.
Negative slope, right? Down 1 over 1, down 1 over 1, and suddenly appears here. And I draw it in. What do I do at my boundary?
Open circle.
Open circle. Perfect. That's the way that was done. Are we feeling better about this?
Yeah.
Okay, online check. You guys feeling better about this? I'm going to do our 7 still. I got a thumbs up. Okay, I got at least 1 thumbs up. That's all I need. I'm moving on. But this board is going to kill me. What the heck? Every day, different problem. All right, I promised I would do number 7 was the other one I said I'd do. All right, number 7. F of x equals, my bracket is 2x, or negative infinity is less than x, which is less than 0. And negative x plus 3 is less than or equal to 0x, which is less than infinity. Yeah? All right. Slap this together. All right. So infinity, 0 to infinity is this side over here. So I'm going over here. I'm going to graph y equals 2x, so that would have a y-intercept of 0, rise of 2, run of 1. Means rise of 2, run of 1 going back this way, draw it in this way. Now the question is, did I blow that part? Yes, I did. It's the open circle. Good so far? All right, and then from here on in, I'm going to do negative x plus 3. So I'm going to go y-intercept of 3, 1, 2, 3. There's 3. Down 1 over 1, down 1 over 1. It's equal to. So I'm going to put a filled-in circle, and I'm going to draw it the way it goes. That looks curved to me. I don't know why. And I don't go left because I can't go less than 0. Deal? All right, deal. I need somebody who was a babysitter or is a babysitter right now. Whoops, that didn't work. Try one more time. Anybody been a babysitter? All right. We're counting on you to tell the truth. You have to tell the truth. One of the things that's funny about this thing is people then try to make up stuff that you now. That's not the way it really works. Babysitting, how do you pay? How does the payment work? You pay by an hour, by the year, what do you pay? By the hour. You get paid by that. Okay, so if you are working, let's say you want to make a wage, what time is it? Make 20 an hour. Okay, see, no more than that high school fee. Get into babysitting. Yeah. Warehouse a budget, get $20 an hour. Make some money. All right, so wait a minute. $20 an hour. Okay, so if you work 1 hour, you make. Wait, no, we all know how this works. 2 hours. 40. I'm going to graph how much money you make versus hours, and then we're going to discover something a little strange about this graph. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'll go 20, 40, 60, 80. So at 1 you make what? 20, 2 you make 40, 3 you make 60. We're all feeling good about that so far. Agreed? Okay. What do you make when you work 3.5 hours? Legitimately, what do you really make? Make 65. Well, it'd be 70 if they gave you half an hour, right?
Oh, yeah.
What if you worked 3 hours and 29 minutes? You still make 70, wouldn't you? What if you worked 3 hours and 22 minutes? Probably 70. In fact, you probably make 70 all the way from 3 hours to 3.5 hours. So something interesting happens here. She makes 70 here, 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 and here by her own admission. Likewise, I assume if you work 2.5 hours and just less than 2.5 hours, you would also do the same thing here. My assumption is once you get past 2.5 hours, you would suddenly start making like 3 hours, right? So you make $60. So suddenly you jump up here. So in real land, a babysitter is a piecewise function graph. Now, if you work 5 minutes and go, oh gosh, we canceled, they're going to pay you something. Apparently in your world they pay you $10. Usually they paid us 20 back in those days, but whatever. So there's my graph. How do you make that with the math you currently know? You can't. This is called the greatest integer function. Greatest integer function. Greatest integer function looks like this. When I do the notation for it, it is f of x equals bracket x bracket. Okay? Now the greatest integer function does the following. It says chop. Doesn't say round, it says chop. So if you get 3 in the greatest integer function, it becomes 3. If you do 3.2, it becomes 3. If it's 3.9, it becomes 3. 3.99, still 3. Agreed? So it says chop, not round, chop. Take your integer and stop there. Okay? So that's what a greatest integer function does, this notation here.